And here's your review for the final exam, starting with problem number 1. The half-life of radium is 1,690 years. If 50 grams are present now, that's our little t, we will use that as our initial amount. The initial amount is 50 grams. How much will be present in 500 years? That's our little t. Our half-life we're given, t sub 1/2 is 1,690. Now, to solve this problem, you're going to use the formula for exponential decay. To get our amount of exponential decay, we will substitute that initial amount, n sub 0, which we're given was 50, times 1/2 raised to the power of little t over big T. Little t is 500. Our big T, the half-life, is going to be 1,690. We substitute those values into the formula. 50 times 1/2 to the power of 500 divided by 1690, we get 40.729. So this is our answer to problem number 1. How many grams are present now? Is approximately 40.729 grams present. Problem number 2, we want to solve this logarithmic equation. We have log base 5 of 3x minus 2 equals 2. First, we want to convert this equation from logarithmic form to exponential form. So remember, if we have exponential form using these variables, y equals b to the power of x, and we convert it to logarithmic form, that will give us log base b of y equals x. And that's what we do first, convert this logarithmic equation to an exponential equation. See, our base 5 becomes the base of the exponent. Raised to the power of 2. 2 is our value of x, so 5 squared gives us 25 on the left side. On the right side of our equal sign, we place the 3x minus 2, and then we solve this equation. So we add 2 to both sides, we'll get 3x equals 27, and then we divide both sides by 3, and we see that 27 divided by 3 gives us our solution, x equals 9, okay? For number 3, we're going to use the change of base formula. Change of base formula to find the log base e of square root 7. Since that base e we want to convert, we're going to use our change of base formula, which is to find the log of our square root 7. So whatever you're finding the log of, that moves to your numerator, and then your base moves to the denominator. We take the log of both. So this is the log. That log should be in the numerator as well. The log of square root 7, find that amount, and then we divide it by the log of e. When we divide those two, we'll get 0.973. This is our solution. Write the expression for number 4 as a sum or difference. So some of those properties of logarithms that we looked at previously involve the multiplication property, division property, our power property, and the change of base like we just used a moment ago. Now, the multiplication property tells us if we're multiplying two terms together, we can separate them as a sum of logs. And that's what we see here, m times n. So we write the equation as a sum, log base a of m plus log base a of n. All right, so if we write it using the exponential form, we would see log with a subscript of letter a for m plus the log with a subscript also of letter a of n. So this would be us rewriting that multiplication, that product of m times n as a sum. So here's our solution. For number 5, we're going to solve this exponential equation. 7 to the power of x minus 3 equals 49. In order to deal with this exponent, we want to take the log of both sides of the equation. So we find the log of 7 raised to the power of x minus 3 equals, we take the log of the right side of our equation, the log of 49. And then we want to apply this power rule. So look at our power rule. When we have our log of x to the power of r, power rule says we can bring down that exponent and multiply it by the log. And that's what we do here. We bring down our exponent of x minus 3, and we multiply it by the log of 7 on the left side of that equation. equals, we just carry down the log 49 on the right side. Then we want to distribute, so we're distributing this x and the minus 3 times the log of 7. When we distribute that x times log 7, we get x log 7. When we distribute the minus 3 times log 7, we get minus 3 log 7. Just carry down the log 49 on the right side of the equation. And now we want to solve. Our goal is to solve for x, right? So we start by first adding 3 log 7 to both sides of the equation. So we're adding that 3 log 7 to both sides. It cancels on the left side. We're left with x log 7 equals log 49 plus the 3 log 7 that we just added to both sides. Then we want to divide both sides of this equation by log 7, right? Divide both sides of the equation by log 7. And remember that goal is to get x, right? So we wind up with x equals log 49 plus 3 log 7 divided by log 7. You can plug this into your calculator. Log 49 plus 3 log 7 divided by log 7. And you should get an approximation of 5. Okay, you'll get this decimal value, which we simplified to 5. For number 6, we want to solve this logarithmic equation. This time we have log base 2 of x equals 3. To solve, we want to first write this logarithmic expression or equation as an exponential one, right? So our base of 2 becomes the base of the exponent, raised to the power of 3 equals x. And we can solve that because we know 2 raised to the third power gives us 8. And that's our solution, x equals 8. For number 7, we're looking at these ordered pairs and we want to determine if the function is one-to-one. And what you want to ask yourself, are all of your y coordinates different? So look at your y coordinates. We have 6, 6, 14, negative 8. Are they different? If they are, then you would say, yes, it's one-to-one. If the y coordinates are not different, then it will not be one-to-one. In this case, we have 2 y coordinates that are the same, y and y. They're not different. Therefore, this is not one-to-one. We would say, no, this is not one-to-one. That's our solution. For number 8, if we're given a graph of a function and asked to determine if the graph is one-to-one, then we're going to perform the horizontal line test. That means drawing horizontal lines through the graph of the function. And what we're looking for is to see if each of those lines intersect the function only one time. If they do, then we'd say yes. In this case, each line intersects the graph only one time. So that means that yes, this function is one-to-one. Number 9, we're given this function h of x equals absolute value of 9x plus 8, and we want to find out whether a, b, c, or d would give us f of g equals h. Now, when we see that f of g equals h, another way to interpret this is f of g. We're saying f of g is equal to letter h, meaning when we simplify this function, we get h. Now, what do we see when we look at our h of x? We see absolute value of 9x plus 8. All right, so if we attempt to find f of g, applying our h function, applying the function that we're given here, for a, we're given f of x equals 9x plus 8. For the g of x, we're given absolute value of x. So if we plug each of these functions and simplify, we want to see which one would give us letter h. Okay, so for letter a, our f of x is 9x plus 8. Our g of x is absolute value of x. So first we would substitute g of x in parentheses, f of g of x. Our g of x is the absolute value of x. And then we have to substitute again using the f function. F function, remember, is 9x plus 8. So we would substitute that absolute value of x right there wherever we see the letter x. So we plug it in as 9 absolute value of x plus 8. This does not simplify. It does not equal letter h. Therefore, we know option A is not correct. Okay, if you were to simplify each of those options, B, C, you'll notice that D is the only option that actually involves that 9x plus 8 and the absolute value. So you may just be able to look at these and determine which one you may want to try first. If you were to do that and you chose option D, finding that f of g of x, we get f of 9x plus 8. Why? Because our g of x is 9x plus 8. We substitute there first. And then when we take f of 9x plus 8, we get absolute value of 9x plus 8. That is the function that we were given right here. We want to know which one gives us this h of x, and that is letter D, the absolute value of 9x plus 8. So our answer would be letter D. For number 10, we want to find each of these functions, a, b, c, and d, when we're given f of x is x squared and g of x equals x squared plus 1. For letter A, f of g, that's f of x squared plus 1. Everywhere we see g of x, we're substituting x squared plus 1. And wherever we see our f of x, we're substituting x squared. And this is what we have here. This is our f of x. And remember, f of x is x squared. We're substituting x squared plus 1 for x, and then we're squaring it, okay? So we get x squared plus 1 squared, which we then need to expand and simplify. So we expanded it as x squared plus 1 times itself, and we distribute it. Multiply each of these terms times each other. X squared times x squared gives us x to the 4th power. X squared times 1 gives us x squared. 1 times x squared, and then 1 times 1 gives us 1. The two middle terms, those are two like terms that can be combined. We get 2x squared. So our final solution, we see x squared plus 2x plus 1. For letter B, g of f of x, and f of x we substituted x squared, and then for our g function, we had the x squared plus 1. So that becomes x squared, and it's also squared. Remember that power to power means we're multiplying 2 times 2. That gives us x to the 4th power plus 1 we carry down. For letter C, f of x. So f of x, we substitute our x squared, and then we substitute again. X squared times x squared. Again, 2 times 2 gives us x to the 4th power. And then letter D, g of x. For g of x, we substituted x squared plus 1, and then we substituted x squared plus 1 again, squared plus 1. Here we needed to expand that binomial expression just like we did a moment ago and distribute. X squared times x squared gives us x to the 4th. 1 times well, 1 times our x squared gives us x squared. 1 times another x squared gives us x squared plus the 1. Combine our like terms. X squared plus x squared gives us 2x squared. And then 1 plus 1 gives us 2. So we have x to the 4th power plus 2x squared plus 2. For 11, we want to find the intercept. Remember, for every x-intercept, our y-coordinate is equal to 0. So we would take that numerator, x squared minus 9, and set it equal to 0 and solve. To solve this, we first add that 9 to both sides of the equation. And that gives us x squared equals 9. To solve, remember the opposite or the inverse of taking the square of squaring a number is to take the square root. So we get x equals plus or minus square root 9. The square root of 9 is 3. So x equals plus or minus 3. Those would be our x-intercepts. If you wanted to write those as ordered pairs, you would write them as 3, 0, and negative 3, 0. The y-intercepts occur whenever our x is equal to 0. So we use our given function, x squared minus 9 divided by x squared minus 16. And everywhere x is, we substitute 0. So 0 squared, that's just 0, 0 squared in the denominator. That leaves us with negative 9 over negative 16. And remember, a negative divided by a negative is positive 9 over 16. If you'd like to write this as an ordered pair, you will write the ordered pair as 0, 9/16. 9/16 being our y coordinate. For number 12, find vertical, horizontal, and oblique asymptotes if they exist for this function. Now, first we want to find the degree of the numerator. Use letter N to represent the degree. See our degree of the numerator. The highest power is 3. So N equals 3. Then the degree of the denominator. The degree of the denominator, we use letter M. Our highest power is 2, so M is 2. Now we'll follow these rules to determine the horizontal asymptotes if they exist. So if n less than m, the horizontal asymptote will be y equals 0. We see our n is not less than m. If n equals m, the horizontal asymptote is y equals a over b. Those are the leading coefficient, but these two are not equal. N is not equal to m. If n is greater than m, there are no horizontal asymptote. So here, n3 is greater than m. So if n is greater than m, there is no horizontal asymptote, and that's what we would say. Since n is greater than m, there are no horizontal asymptotes. And then we move on to vertical asymptote. Vertical asymptotes occur when the denominator is equal to 0. So we take our denominator and set our denominator equal to 0. X squared minus 6x plus 5, we factor using x minus 5, x minus 1 equals 0. And then we solve by setting both of these equations equal to 0. So we'll get x equals 5 and x equals 1. Now we do have to go back and then double check to make sure that when we are at x equals 5 and x equals 1, that the denominator equals 0 and the numerator is some other number that's not 1. All right, so if we substitute 5 here in our denominator, we'll get 5 squared, that's 25, minus 6 times 5, or 30, plus 5. That gives us 0 in the denominator. However, in the numerator, we also get 5 cubed. 5 cubed is 125 minus 125. So that's 0 in the numerator and 0 in the denominator. Therefore, that x equals 5 will not be a vertical asymptote, because in order for it to be a vertical asymptote, the denominator must be 0 and the numerator cannot be 0. Any other number, not 0. In this case, it is. So x equals 5 would not be a vertical asymptote. Now we'll check for if when we plug in x equals 1, what happens? So 1 squared, we'll get 1 minus 6 times 1, that's minus 6, plus that 5, that will give us 0 in the denominator. In the numerator, 1 cubed minus 125, that'll give us negative 124. So that's a number that is not 0. Therefore, x equals 1 would be our vertical asymptote. All right, so we'll write x equals 1 as our vertical asymptote. Oblique asymptotes occur when the degree of the numerator is exactly 1 greater than the degree of the denominator, and that's what we have here. Remember, the degree of our numerator is 3, the degree of the denominator is 2. That is 1 more than the denominator. Therefore, we have a oblique asymptote. To find the oblique asymptote, we have to divide. All right, and look at our polynomial. We have x squared minus 6x plus 5 in the denominator. We're dividing that into x cubed minus 125. Okay, so we wrote it here. X squared minus 6x plus 5 divided into x cubed minus 6x plus 5. We had to add a value to represent x squared since we did not have an x squared term. So we had to add this part. When we divide, we're looking to see how many times or what do we multiply x squared by to get x cubed, and that's x. All right, x, we would distribute. X times x squared gives us x cubed. X times the minus 6 gives us minus 6x. And well, 6x squared, since we have two x terms, and then x times that 5 gives us plus 5x. The x cubes cancel out, and then 0x squared minus negative 6x squared. Remember, negative times negative, this becomes positive 6x squared. Negative 6x minus 5x, that's two negatives now, it gives us negative 11x. And then we carry down that plus 5 on the end, and we subtract here after we determine what do we multiply the x squared by. So we're going back to our x squared term, and we want to determine what we multiply x squared by to get 6x squared, and it's 6. So we place the 6 there next to our x, and we distribute the number 6. All right, so 6 times x squared, we get 6x squared. 6 times the minus 6x, we get negative 36x. And then 6 times 5, we get plus 30. Subtract 6x squared cancel. Negative 11x minus negative 36, that becomes positive 25x. 5 minus the 30, that gives us negative 25. All right, see the x plus 6 above the line? This is going to be the equation for our oblique asymptote. The equation for our oblique asymptote is y equals, write it as an equation, x plus 6. All right, now for number 13, we want to find the domain of the rational function 12x over x plus 2. First, you want to set that denominator equal to 0 and solve, because remember, the domain are all of your potential x coordinates, and we cannot have 0 in the denominator, so we need to determine which values will make our denominator equal to 0. Set x plus 2 equal to 0 and solve. That means subtract 2 from both sides. And we'll get x equals negative 2. So when x equals negative 2, that denominator is 0. Therefore, x can be any other number except for negative 2. X cannot equal negative 2. And that's how we want to describe it. If you wanted to describe that using interval notation, right, we are saying that any number on that number line would work except for a negative 2. So x could be a value from negative infinity to negative 2. We should put parentheses around both. Or x could be a value from negative 2 to infinity. Again, you want to put parentheses around both. For 14, determine whether we have a polynomial function, and if so, you want to find the degree. All right, so we have f of x equals x times x cubed minus 6. First, we need to distribute here. When we distribute, we get x to the 4th power. Remember, this is a 1 here. We add those powers. That gives us x to the 4th power minus 6x. Yes, this is a polynomial function. The degree is going to be our highest power, so our degree is 4. And our leading coefficient is the number that is in front. And that is a 1 here. So our leading coefficient is 1. Our degree is 4. Number 15, the price in dollars, P, and the quantity X is sold for a certain product to satisfy. This is our demand equation. X equals negative 7P plus 700. And we want to find a model that expresses the revenue as a function of P, remembering that R equals X times P. So here's our demand equation that's given to us. The revenue formula, R equals XP. So we're going to use that revenue function to help us first find an equation for the revenue. Substituting our value for X that we were given, X equals negative 7P plus 700, and then we're going to distribute P. P times that negative 7P gives us negative 7P squared, and then 700 times P gives us 700P. So here's our revenue function that we'll use to help us later on. Now we want to find the domain. The domain, of course, since we're talking about funding and finances, we're going to assume that our R is a positive number, and the domain would be all of the possible value of prices that would help us obtain this revenue. So therefore, we want values of X, negative 7P plus 700. This is our formula, our equation for X, that are greater than or equal to 0. We want non-negative numbers, okay? So we want to look at this scenario. We want values of 7P that are greater than or equal to negative 700 when we're looking at our quantity. All right, so here we have X. We want our 7Ps to be greater than or equal. So we want, if we use these two pieces of information, we want values of negative 7P plus 700, values of that X that are greater than or equal to 0. To solve this inequality, we would subtract 700 from both sides of the inequality. So we'll get negative 7P greater than or equal to negative 700. And then we would divide both sides by negative 7. Remember, when you multiply or divide by a negative number, you have to reverse this inequality. So it changes from being greater than or equal to less than or equal to. So we want values of p that are less than or equal to negative 700 divided by negative 7 gives us 100. So we want values of p that are less than or equal to 100. This is the domain that we're looking at. Values of r and p that are that gives us in that range, right? Less than or equal to 0. So anywhere from 0 to 100, since we want values specifically that are greater than 0. After you find your domain, you want to find the price P that maximizes the revenue. To find that maximum point, if we look at our function, us having a leading coefficient that's a negative number, we know that this will create an inverted shape. So that vertex will give us that maximum revenue point. Remember, to find that height, that coordinate, we would use our formula to find the vertex. We're particularly looking for that value of that x coordinate, negative b over 2a. Given this function, our original function that we were given, negative 7p squared plus 700, our b term, we have negative b. Our negative b is going to be negative 700, all right, using that b term. Divided by 2 times a, our a term right here is negative 7. So 2 times negative 7 and the denominator becomes negative 14. And we divide that negative 14 into negative 700, that gives us 50. So here is the price point P that's going to maximize our revenue. So if we write that in the form of money, we will write it as $50. Now we know the price point that maximizes our revenue. Let's find the maximum amount. The maximum revenue is given by our revenue function, which we just simplified to find. Our revenue function from earlier, our R of X, we were given that function that we substitute here. All right, we got our R of X, which equals negative 7p squared plus 700p. And now we have our price point of 50. We're going to substitute 50 for p. Everywhere we see the letter p, we have negative 7 times 50 squared. That gives us negative 100 or 17,500. And then 700 times 50, that's 700 times p, gives us 35,000. Add these together and we get our value here. All right, so you get your revenue, your maximum revenue as 17,500. What price should the company charge to earn at least $11,200 in revenue? So if you want your revenue to be at least 11,200, you want it to be a minimum of 11,000, but it could be a number that's greater than that 11,200. Okay, when we substitute that amount into our formula, we're going to use quadratic formula. All right, our quadratic equation, right? Our goal is to determine which of these functions is going to give us an amount that is at minimum 11,200. So of course we had to subtract that 11,200 from both sides. That's where we get our quadratic equation. Negative 7p squared plus 700p minus 11,200. Okay, so it's using the given function. Let me just back up a little bit. Given function 7p squared plus 700p, our revenue function. We want this to be a number that is greater than or equal to 11,200. We want to treat it as an equation and subtract that 11,200 from both sides. All right, and we do that. That's how we get our negative 7p squared plus 700p minus 11,200 equals 0. Applying our quadratic formula, where a equals negative 7, b equals 700, and c equals negative 11,200, we substitute these numbers into our quadratic formula. We get negative 700 plus or minus square root 700 squared minus 4 times minus 7 times 11,200, all divided by 2 times negative 7. And when we simplify, we get 20 or 80. So we want those prices to be between $20 and $80 in order to maximize our revenue. Next question, determine whether f of x equals negative 6x cubed is even, odd, or neither. Now, just as a note, if a function is even, you substitute negative x for x, and when you simplify it, you'll wind up with the original function that you started with. If a function is odd, when you substitute negative x for x, you'll get negative in front of that original function. So in our case, since our function is negative, if we wind up with a positive, the opposite sign, then the function is odd. So of course, we got to substitute. We have to replace our x coordinate with negative x. And when we do that, negative x cubed, that becomes negative x cubed. But negative times negative will make this a positive 6x cubed. Okay, that's not equivalent to what we started with, so it's not an even function. Next, if we substitute negative in front of our f of x, right, and compare these two functions, if we put negative in front of our 6x cubed, negative times negative, that gives us a positive 6x cubed. And remember, if we get the original function compared and we wind up with the inverse of the original function, which we do, the inverse is positive instead of negative, that indicates that this is an odd function. Next, we want to be given this value, x equals negative 2, and we want to find the value of the expression 5x squared minus 4x plus 1 over x. So everywhere x is in our function, we substitute negative 2. 5 times negative 2 squared. That negative 2 squared, that gives us 4 times the 5, simplifies to be 20. And then negative 4 times negative 2, that gives us positive 8, plus 1 divided by negative 2, that's plus 1/2, and minus 1/2. And we add these together, subtract the 1/2, and we wind up with our solution, 27.5. The velocity for the next problem of a falling object is directly proportional to the time t. If after 2 seconds, the velocity of the object is 64 seconds, what will the velocity be after 6 seconds? Okay, so considering our distance formula, distance is equal to rate times time, rate applying to our velocity is equal to distance over time. If we're given direct proportionality, we have a direct relationship between two variables. In this case, we use v and t, but we also in our formula use y equals kx. It's the same thing. Y and x are going to be two quantities. K represents the constant of proportionality, and that's always going to be your first step to find that constant of proportionality. If we are given a problem that has indirect proportionality, that means when you compare y and x, it becomes a division problem. It's k over x instead of k times x. All right, for this problem, we're using direct proportionality between v and t. So our letters are v and t instead of y and x. We write our direct proportionality equation as v equals k times t. We're given the velocity of 64, right? We're given that in our problem. And we're also given a time of 2. Okay, so we use both of those values, a time of 2, the velocity of 64, in order to find k, our constant of proportionality. And to do that, we just divide both sides of the equation by 2. So we get k equals 2, k equals 32. After you find the constant of proportionality, step 2 is to then find the velocity of the portion we're concerned about. We want to find the velocity after 6 seconds. So see in our question, we want to find the velocity after 6 seconds. So we'll take our direct proportionality equation, remember v equals k times t, and now we want to substitute our constant of proportionality that we just learned, k equals 32, and the time 6 seconds that we were given, and then we're going to multiply those two together to get our velocity. So 32 times 6 gives us our answer. Our velocity is 192 feet per second. For 19, we want to find the standard form and the general form of an equation of a circle. Radius r and center is hk. And we're given both of those two pieces of information. Our radius is 10. Our center is -7, -8. Standard form of an equation, x minus h squared plus y minus k squared equals r squared. And we just substitute h, k, and r, and then we simplify. So we get x minus minus, remember minus minus, this becomes addition. So x plus 6 squared plus, again, minus minus, y minus -8 gives us y plus 8 squared, and then 10 squared gives us 100. Here's our standard form of the equation of this circle. The general form equation is x squared plus y squared plus 2 times gx plus 2 times fx equals 0. Now, in this particular function, our h and k are the values that we're using for g and f. So for our 6 times 2, we get 12, and our 8 times 2, we get 16. And we just leave it in this form for our general form of the equation. Find the distance between 2 points. We have point 1 at 0, 0, point 2 at 6, 1. And here's our distance formula. Take the square root of the difference between the x coordinates, x2 minus x1 squared, so 6 minus 0 squared, plus the difference in the y coordinates, so 1 minus 0 squared. That simplifies. Here's 6 minus 0, that's 36, plus the 1 squared, that gives us square root 37. 21, we want to solve this absolute value inequality. Now, our inequality problems will sometimes be greater than and sometimes be less than. If we're given a function with greater than, then you're going to make an expression taking those terms that are underneath. You would, and if it were this problem, you would say 2x, make it greater than that positive 6. So positive 6, whatever's on the right side, or we always put an or statement there, 2x less than -6. All right, we take 2 of those. Anytime we see that greater than symbol. If we see the less than symbol like we have in our problem, then you're going to place this expression, that 2x, in a compound inequality between the positive and -6, always putting the smaller number on the left and the larger number on the right. So this is how we set up our inequality. We set it up as -6 less than 2x less than 6. And then to solve, we have to divide the middle, the right, and the left side of this inequality by 2. -6 divided by 2 gives us -3. In the middle, the 2's cancel out, so we get x by itself. And on the right side, 6 divided by 2 gives us 3. But this is our solution. X is between -3 and 3. Solve this equation. We got x squared plus 4x equals 12. First, we want to put this in standard quadratic form, so we subtract that 12 from both sides, giving us x squared plus 4x minus 12. And we can factor this using 6 and -2. Remember, two numbers that multiply together to give us -12, but that have a sum of 4. X plus 6 and x minus 2 equals 0. And then we solve, set both of these factors equal to 0. X plus 6 equals 0. Or x minus 2 equals 0, and we wind up with -6 or +2, okay? And we remember how to do those things. X plus 6 equals 0, solve that equation. We subtract that 6 from both sides, so we get -6. Or that x minus 2 equals 0. Remember, we're going to add this 2 to both sides, so we'll get +2. And here's our solutions, -6 or 2. And that is the last problem. Good luck on your final exam.